Hello guys, welcome to my channel. In today's video I would like to explain to you how to read a motor nameplate and how to do a mechanical inspection on a motor. So in front of us we've got a three-phase motor and coupled with a high pressure centrifugal pump. So this side, this is the pump, and then the red one is the coupling. So there's a shaft that couples the two devices. Then the green item you see on the side is a motor. And then if you look closely here, this is the motor nameplate. This is a very important part of the motor. It contains important information: the type of voltage, the amount of power, the speed that can be generated by this motor, the power factor conditions, the efficiency, and the configuration, how you connect the motor. And then this is the motor, like I said, and it's got many important parts that you need to know in terms of their names and their functions. Okay, I think let's start with the motor nameplate. Alright, so looking at the motor nameplate, I'm just gonna focus on the most important parameters. We have V on the left. Those are the parameters, voltage parameters, and it depends on the voltage system that you're gonna be connecting your motor to, and also the configuration. Let's say you're connecting the motor in star or in delta. And then we've got frequencies. We've got two frequencies there. It can either be a 50 Hertz frequency or 60 Hertz. Most of the time, if you are in South Africa, you're gonna be dealing with 50 Hertz. And then in other countries like USA and the associated countries, they will be dealing with 60 Hertz. The power rating, sometimes it will be displayed in kilowatts, but in other cases it's gonna be displayed in horsepowers. But you can always convert horsepower to kilowatt. Then RPM is your maximum speed, motor speed. You can see that value, it corresponds to the voltage, meaning for a 525 to 910 volt system, that's the maximum speed. But if you put it on a higher frequency, like it's 630 volts delta and 60 Hertz frequency, you're gonna get the higher speed, that 3574 at the bottom. And then you get current. Like you can see, the current and voltage is also split into two. The current on the left is the current you subject your motor to when you're connecting it in delta. And then the current on the right is the current the motor will experience when it's connected in star. And then we've got power factor. The power factor is corresponding to the type of voltage that you are subjecting your motor to. And then on the right is just the different efficiencies depending on the amount of voltage you expose your motor. It's gonna have different efficiencies. Then here at the bottom, obviously, if you understand the electrical engineering, it's just explained to you how you connect your terminals when your motor is in delta, and how you connect your terminals when your motor is in star. Y is like star, Y, and then the delta triangle is for delta. Okay, I think we've covered the most important parameters on the motor. Now let's go just to the components of the motor for you to understand what are the important components in the motor and what are they called. Okay, like as we started, the first and the most important part of the motor is the nameplate, because it's what tells you all the details. It's like the ID document for that motor. And then at the back we've got a fan cover and a fan. We've got a fan here with blades. It's for cooling the motor. And then we've got an eye bolt here. That eye bolt is for lifting the motor. You can see this motor is very big, so you usually use a crane, chain block, or any other lifting equipment to lift it higher. And then we've got these fins. These fins is for cooling. They also encourage the motor cooling, but that's a motor body. This side of the motor, the back side, is called non-drive end, because the load is connected to the other side. The side where the load is connected, this side, is called the drive end, and this one is called the non-drive end. So on the non-drive end, you're also gonna have a bearing, but we can't see the bearing because it's inside. and we've got a shaft and the rotor. There's also inside, we cannot see those ones. And we've got the motor footing, the foot piece. This one is for mounting the motor, obviously. And then we've got a stud for connecting the earth wire. Internally, inside the terminal box, the motor has got a part where you can connect the earth, but you also earth the frame of the motor. Okay, so in addition to the components that we've already mentioned, this motor also has a terminal box cover. The main terminal box cover is where your electrical connection, the cable that is bringing electricity to this motor, is going to be connected. And then we've got an extra terminal box. That one is used for a thermistor and for the heater. So this motor has got a heater and a thermistor. The heater is just to prevent the motor from freezing. Let's say you install this motor in a very cold environment, and then it ice starting to build up. It's just to keep the motor a bit warm. The thermistor obviously is to prevent the motor from overheating. So it's going to be wired to the electrical control circuit, so that when the temperature is exceeded, it can cut off the supply to the voltage. Okay, and then I think I did mention most of the most important mechanical parts. In my next video, I will try to cover the electrical motor test, but for now we are looking at the visual inspection. So when we look at the visual inspection, we're looking at the mechanical condition of the motor, which is the condition of these eyeballs between this terminal box and the motor. You also get a gasket. You make sure that the fan is there and it's not broken. We hold the shaft and feel the bearing if it's not seized. But with this motor, we've got two bearings. We've got a bearing on the drive end and the bearing on the non-drive end. So the visual inspection of the motor is just looking at the mechanical condition and if all the components of the motor are functioning properly. Some motors will have a brake, a motor brake that is built into it to slow down the motor. Yeah, you do get the motor with very different features and extras, but basically the function of the motor is to convert electrical energy to mechanical energy. Very important component used in industry to drive a lot of loads. Like this one is used to drive this pump, but you can use a similar or same size type of a motor to drive an agitator, to drive a conveyor, and to drive in many other things. Okay, thank you so much for watching this video, and if you like the video, please do click on the like button, and also do subscribe to the channel so that the channel can grow and that we continue to share this type of content. And also please do share the video with anyone who will find it beneficial. Thank you so much for watching. Enjoy the rest of your day. Goodbye.